Hi everyone. So now we're looking at how to find a quadratic equation from a table, and we're going to look at the general equation and we're going to blow it up so that we can see how it actually works. So if we start with y equals ax squared plus bx plus c, which is the general equation for a quadratic equation, we can make a difference table with it. So what we're going to do is we're going to put where x is -2 and then -1 and then 0, then 1 and then 2, and then find out what the corresponding y value is. So y of -2, substituting -2, I get 4a take 2b plus c, and I put it here. Do the same for 1, I get a minus b plus c, put it here. Put in 0, if I put 0 in here, that becomes 0, that becomes 0, that becomes c. That's where that c comes from. Do the same for 1, I'll get this, and do the same for 2, and I'll get this. Now to find the first difference, we subtract this from this. So that's what I've done here. A take 2b take c minus the whole of this bracket. So that minus that. And that will give us -3 plus b. And that's our first difference value. And then we do the same for this one, and this one, and this one. And we'll get these three values here. And then we do the same for the second difference, which I haven't labeled, so I will. And if I have that and I take away that, which is what I did here, I'll get 2a, and that take that will give me 2a, and that take that will give me 2a. And that gives us a few interesting features in that 2a is the same as we'd expect, and that if we want a, we just have to halve whatever value is here. And we can get c by looking at the value underneath 0, and we can get a plus b by substituting in whatever our value for a is here and equating it to the value that's there. Now, it sounds very complicated. It's actually quite easy to do. Here's our first table. We're given these values. That take that gives me this one. That take that gives me this one, so on and so forth. That take that gives me this one, so on and so forth. Now, when we get to this point, we can find the coefficients of x squared and x and c by looking at this table. This value here is going to be c. That's where I get this 3 from. This value here is going to be twice what a is. So if I halve it, I'll get a. That gives me a is 1. That gives me this value here. And I know that this value here has to be a plus b from our generalized equation. And if that has to be a plus b, if a is 1 and the equation has to equal 3, b must be 2. And that's where that value there comes from. Simplify this, I get the equation, or the function, for this table of values. And I could use that to find any other value for y that would correspond to x that would be on the curve. Here's a second example. Shouldn't really put the answer up here. Let me get rid of that quickly. We're given this table here, and we're trying to find out the equation for it. All would be given is this part. Then I subtracted them. As before, 5 take 3 gives me 2, 11 take 5 gives me 6, 21 take 11 gives me 10. Finish that part, and then did it again. 6 take 2 gives me 4, 10 take 6 gives me 4, 14 take 10 gives me 4. Now I can find out my a, b, and c values, or my coefficients of x squared, x, and c at the end, the constant. The constant is 3. It's the value that sits underneath x equals 0. I find a by halving this value down here in the second difference. Half of 4 is 2. That gives me the coefficient of x squared. And if I want to find out b, it's just a plus b equals to whatever's here. A is 2. There's b, there's 2, b must be 0. So I put 0 over here. And now if I simplify that, I end up with y equals 2x squared plus 3. Let's check if that works. 2 times 4 is 8, plus 3 is 11. 2 times 1 is 2, plus 3 is 5. 2 times 0 is 0, plus 3 is 0. Yeah, it works. And there we go. There's a fairly simple way of finding a quadratic equation from a table of values. Hope that helps.